And welcome everybody to the Daily Space Weather Show. We've got all your solar imagery, a cosmic ray report, coronal mass ejections, a coronal hole high-speed stream showing up as we make the video, and some other choice tidbits to cover. That's a 24-hour video there from Solar Dynamics Observatory. Here's another in a different wavelength. You may see some activity right there in the southern central part of the solar disk. Again, we had multiple coronal mass ejections since yesterday. We'll cover it, as well as some forecasts from ESA and from NOAA. And before we move on, make sure you press the like button. If you're new to the channel, press subscribe, press share, leave a comment, visit the links below the video, help support the channel. Thanks to everybody who has. Let's have a little science quote. Another one from Carl Sagan here. Somewhere something incredible is waiting to be known. It's a reason to do science. You never know what's going to happen. In fact, you may find yourself with answers to questions not asked. So let's talk about some answers to questions. If anybody's been telling you that, quote, energy from space is increasing, it's simply not true. Cosmic ray flux is at the lowest level in 20 years. So we're going to look at 7 different monitors here. Here are Apatit and Barentsburg. You can see there is a slight uptick there at Apatit over the past 30 days, and a slight uptick at Barentsburg as well. Don't expect that to continue. We still are not at solar maximum. Next, we'll go to Athens, Greece, and we'll ignore that because that's not enough data to say what's been going on for the past month, although we have had some large fluctuations in the past few days. I keep hitting the wrong button here. Mexico City has been flat over the past 30 days. Next, we'll go to Oulu, Finland. Oulu, Finland, a slight uptick over the past 30 days, similar to Apatit and Barentsburg. And notice this bottom graph. You see right there? Lowest levels since 2004, which means lowest cosmic ray flux since 2004. And the rest of the monitors will agree with that. Next, some Antarctican monitors, a little uptick at DOMC Antarctica, and a little uptick at DOMB Antarctica. The 10.7 centimeter radial, and keep in mind, folks, cosmic ray flux lags solar activity sunspot number by about 5 months. So the 10.7 centimeter radial flux is now at 194 solar flux units. There it is in the 1-year graph depicted by that black line as we keep seeing higher lows. So expect to see some higher highs coming too between now and October when we expect solar maximum to arrive. So here's a forecast from NOAA. NOAA's expecting a geomagnetic storm here coming on Friday night. Friday night into Saturday morning there. So that's a CME impact. It's a very slow-moving coronal mass ejection. And here's NOAA's Enlil spiral. So that's NOAA's forecast. ESA's forecast is very similar. And I do believe I said in yesterday's video that I don't think that's an earthly directed coronal mass ejection, so we'll have to see what happens. I think they have forecasted a false alarm, but that's pretty rare. So we'll have to see who's right here. There's ESA's Enlil spiral, the European Space Agency. And pretty much they're in agreement, although expecting a little higher density spike there than NOAA. Here are the past 4 hours of what Earth's magnetic moment from space likely looks like. This depicts magnetohydrodynamic pressure. The Geospace Magnetosphere movie relies on a space weather modeling framework, which uses a whole series of different variables to calculate the likely pressure, magnetohydrodynamic pressure, out to about 12 Earth diameters. So that's what you're seeing there. That is what Earth's magnetosphere looks like. And if you're wondering where the GOES 16 and GOES 18 are, they're in the outer portion of the outer Van Allen belts. So if you look at the 2 plasma spheres you can see there, the outer plasma sphere is sort of the border where you'll find those satellites. They're geosynchronous near equatorial satellites. So here are our ground magnetic perturbations map. This depicts magnetic flux density at the surface level, and things are calm. It is geomagnetically calm at the moment. No likelihood of large chances of auroras here at mid-latitudes tonight or anything like that. Hopefully Friday night things will change. Hopefully I'll be wrong. KP index is 2.33. That's an average of global geomagnetism. 2.33 is the current KP index. And check it out. It looks like a coronal hole high-speed stream has just started to arrive. So that was a little unexpected. Nobody really forecasting that one, I don't think. So there's the data from ACE, located at Lagrangian point 1. So ACE returning about 8.3 protons per cubic centimeter at 350 kilometers per second. Discover a much denser solar wind there, quite a bit denser, about 50% denser, at 12.86 protons per cubic centimeter, similar solar wind speed. So if we see that density drop off and the velocity come up, especially when accompanied by a signal in the lower bar there, the plasma temperature, that is an indication that it indeed is a coronal hole high-speed stream. Don't expect this one to be real long-lasting because there were not major coronal hole features associated with this stream. Continuing on, there are our GOES magnetometers. Now they are located where I just described, in the outer portion of the outer Van Allen belt. And we are seeing some sawtooth readings and some divergent readings there between the GOES 16 and the GOES 18 for the past 24 hours. Next, the heliosphere. We can expect Earth to stay in a North Pole magnetic sector here for the foreseeable future, although we are seeing some indecision there east of Earth. If you look at the last frame here, you'll see no South Pole magnetic sector there in the nearby area. However, don't be surprised to see that rapidly change. The magnetic environment can change with essentially no warning. Here's our line of sight field plot. And if you don't know what's depicted, just ask in the comments, and perhaps even one of our viewers will let you know what is depicted in that fantastic set of data. So here is our line of sight coronal hole plot. We are seeing some South Pole oriented coronal holes here, but mostly north. So we may see some additional instability there in the eastern quadrant of the Earth-facing portion of the solar disk. Let's move to coronal holes from SDO. So there's the 211 angstroms wavelength, and we can expect to see those coronal holes in the northeast become a little bit more well-defined in the coming couple of days. No major plasma motions over there, so this may rely on sunspots. Now keep in mind, folks, sunspots essentially are like magnetic high-pressure zones. They constrain magnetic fields. And coronal holes are like magnetic low-pressure zones. They project magnetic fields out into the greater solar system. So that's a great way to think about it. Coronal holes are kind of like low-pressure systems. Sunspots are kind of like high-pressure systems, and completely dissimilar to any Earth weather. Moving on to sunspots. Sunspot number has jumped all the way up to about 178. So there you go. 178 sunspots is the current sunspot number. Here's our flare probability monitor and scoreboard. And we still do have a significant possibility of large solar flares. Now, we do have a new unnamed group. That'll be known as sunspot 3729, near the equator there, right over the eastern limb. So that's moving forward. That will be a place to watch for large flares. And still a significant possibility of large flares at sunspot 3723, but that has dropped significantly since yesterday. Let's move to sunspots from SDO. So, we can cut to this too. There is the potential field surface source, magnetogram, along with the named sunspot groups. All right, so there's the SDO 24-hour video at 30 frames per second, the SDO HMI instrument. There is your magnetogram. And not a lot of evolution of sunspots over the past 24 hours. Most have been stable. Once again, the most active region is certainly in the southeast. So those groups there will be the most likely place to see large solar flares moving forward. That group that just rose over the eastern limb there near the equator, and 3723 south of the Earth scale. And there is that same view in SDO magnetogram. So that's what's going on with sunspots. If I had to guess, I would say the most likely place for a large solar flare would be near the equator on the east. I think that new sunspot, sunspot 3729, it will be named, is the most likely place, despite it not having produced any significant flares so far. So moving right along here to energetic particles and flares. Excuse me. All right, so the ghost proton flux is baseline here, and don't expect that to see any big spikes in the coming days here. We don't have any sunspots close to the western limb, so proton flux remains pretty calm, and in fact the X-ray background flux has dropped way down to about a C1.5. So really a decrease in solar activity despite an increase in sunspot number since yesterday. It does take about a day for the sunspots to get counted, so you could think of the sunspot number as a bit of a lagging indicator. The radio and X-ray flux, they're instantaneous. That's picked up as soon as the electromagnetic radiation is received at the instruments. Whereas sunspots have to be counted, they have to be on the solar disk, Earth-facing for 12 or more hours, and so on. So next are 94 angstroms wavelength from SDO. We've got two areas of flaring there, one on the south central solar disk, and then also sunspot 3723. They're only C-class intensifications there, so nothing to really write home about. And let's do a solar system forecast next. Here's what's been going on. Here's what is going on in the solar system. That's what'll be going on in 1 week. Will be only one day from Independence Day, July 4th. And also Saturn will go into retrograde. I'm sure that means something to somebody. Here's a star chart of what's going on over our head. That's skyandtelescope.org if you want to make your own. I don't know why they've put a giant X at the bottom of the screen, but for some reason it's there. Hopefully it's not because they are pathetic, drooling Elon Musk fanboys. Let's hope not, as that is very sad. Very sad. We've got Jupiter setting along with the Pleiades. Also Venus and Mercury setting behind the sun there. And let's go to the astronomy photo of the day. It's really a video. And this features the Milky Way galaxy, some aurora, and some SARs, which, if you see there's like a red arcing feature there, that red arcing feature, that's called an SAR, which was misnamed, and I guess they're still referred to as SARs for some reason. It stands for Stable Auroral Red Arc, and they're actually not auroras, and they're not stable. They're an indication of heat leaving the Earth's upper atmosphere. So really those are Earth-generated, those SARs, that red arc you can see there in that imagery. That's the astronomy photo of the day. And if you want to read about SARs, you can go to apod.nasa.gov, and there's a great article that you can read about stable auroral red arcs. Again, they're not actually the aurora. They're heat escaping the Earth system. And there's an interesting write-up about that and links to some more articles if you like. Moving on to CMEs. And there were multiple events throughout the day today. None of them appear to be earthly directed. So this is 85 frames from today. You'll see one out of the southwest, one out of the northeast, one out of the northeast. That's 3. One out of the southeast. And yeah, it's pretty chill as far as CMEs. And we'll tie those all together with our composite imagery here in just a minute. There's LASCO C2 and C3 together. We'll also show stereo A, which is located where that red dot is, that red A there. That is where stereo A is located as it speeds away from Earth in a slightly closer orbit to the Sun. It'll also show you the location of the Solar Orbiter, the Parker Solar Probe, Bepi Colombo. Stereo B would be the blue dot. So here's stereo A, and yeah, no earthly directed coronal mass ejections as far as I'm concerned, which makes me not very concerned. So, not that I'd be concerned anyway, I'd just be delighted that we're going to be likely to see the aurora at mid-latitudes. So, but unfortunately, not really the case. It's another 24-hour video, 30 frames per second there. We'll also zoom in a little bit closer. We've also added 193 angstroms running difference imagery to give some fantastic contrast to coronal filaments. And we'll come back to that in just a minute. First, filaments from Cerro Tololo. So quite a lot of filaments there, mainly on the eastern portion of the Earth-facing disk, which means likelihood of coronal mass ejections going into tomorrow is just this side of 100% once again. We'll also show the grayscale imagery. There you go. A couple of prominences there rising in the east also, so perhaps some new active regions about to make their way over that eastern limb. Fingers crossed for that. And before we get the bonus features, here are the past couple of hours from the GOES 16 SUVI. We'll zoom out so you can see timestamps. There you go. This video was recorded at 4:39 p.m. Eastern Daylight Time. All right, here come bonus features, starting out with satellite charging hazards. We've got some minor surface charging hazards there over Southeast Asia, South Central Asia, etc. Don't expect any major communication breakdowns from those. Electron flux here is low. That is the 3-day chart from the GOES 16 and GOES 18's radiographic measurements. Now they're at very high orbits, and they're measuring using radiography the electron flux at the F layer. So they're at about 23,500 miles of altitude. The F layer is way down at 300 kilometers of altitude. Here's the forecast model. NOAA expecting slightly lower levels in the coming days. And if their forecast for a CME impact is correct, I would agree. However, we may see lower levels more quickly since there appears to be a coronal hole high-speed stream arriving, as we mentioned earlier in the video. Next to layer where it's measured, like I said, the F layer is at about 300 kilometers of altitude, and here it is, the ionosonde from the Australian Government Bureau of Meteorology. So things looking pretty normal there. No real surprises. No apocalyptic forecasts. No frills. No propaganda. No nonsense. Although the South Atlantic anomaly is on the coastline of South America now, instead of in the middle of the continent, right where the 45-degree west longitude line hits the South American coastline. So that's been there for a couple of weeks now. So that's always interesting. But besides that, not a lot going on. Ionosphere looking quite normal. That's the anomaly in megahertz from a 30-day median. Next, the global ionosphere nowcast. GPS users might benefit from the left images. Radio users might benefit from the right images. That's the WAM, the whole atmosphere model, the global ionosphere nowcast. Some high-res images. And there's that new sunspot. It is beta gamma class, but is it beta gamma delta class? It is, but barely. It does have some deltas in the middle, so now as far as these other groups go, let's see if we can fit those all on the screen. That's pretty good. There we are. So these have lost magnetic shear since yesterday. So I would say the most likely place for a large flare is, again, this sunspot group right over here, the one that just rose over the eastern limb, just south of the equator. We'll close out with some more fresh images. There is our 304 plus 193 angstrom 60-minute running difference imagery. Again, keep an eye on those filaments. We'll be doing it. You should too. We encourage more people to get involved in space weather, as there's a lot of work to do and a lot of emphasis on private space flight, as private space flight is going to become more and more affordable for more and more people to do. Go up in space for a little period of time, spend a boatload of cash, and you'll get to say, hey, I've been to space. So anyway, thanks for joining us in space. We'll see you soon. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.